Hello guys, welcome back to In 5 Minutes. In this session we are going to see VHDl code for 4-bit binary down counter. Okay, in the earlier session we have seen the up counter. In this session we are going to see the down counter. So starting with the library declaration, we have to use library IEEE, in which we are going to use the family library, use IEEE standard logic family 1164 and standard logic unsigned.all. After that, for the 4-bit down counter, for which let us see if I am choosing that this should be my down counter, if this box is working as a down counter. So what will be the input and output interface for this one? So this is basically the counter, okay, to which the entity declaration is there, and you know this stuff. Syntax to declare the entity, since the VHDl is case insensitive language, the syntax is entity, counter is the name of entity, is, so it is nothing but the input output interface. So for port input side, input port, clock and clear we have. So this is the clock and the clear. So these are the input standard logic from the input side. So this is my input side. At the output side we have Q. Now Q is a standard logic vector. For that I have a bus arrow, which is nothing but Q, or you can call it as, it is 3 down to 0, so it's a bit vector having 4 bits, Q3, Q2, Q1 and Q0. So this is going to be my down counter, and these 4 bits are counting downs, 3 down to 0. Q is going to show me the output. So this is the only interface I have with the down counter. So I'll end the entity here, and the syntax is end and entity name. To define the architecture part, the architecture syntax is architecture. This one is the name of architecture, architecture of name of entity as it is, that is nothing but here I am using the entity name counter, so that will be copied here. Architecture archi of counter. We are going to require a temporary signal because the data is continuously changing since it is a down counter. So temporary signal is defined as a standard logic vector, again 3 down to 0. Next we have to begin the process. So while beginning the process, clock and clear, these are the sensitivities for the process. Means what? Whenever the clock or the clear, this input change, then the process will be executed. And how should be the execution of the process? Let us see. Very first thing in the begin, if clear is 1, then the counter should be set to 1 1 1 1. Hence I am setting signal TMP, that is nothing but the temporary logic vector TMP should be assigned the value 1 1 1 1. That is nothing but all set, that is nothing but the highest value to count from down. So all set to all reset, that is nothing but 1 1 1 1 all the way to 0 0 0 0. This is the count operation, since this is a down counter. Okay, so if the clear pulse is 1, that is the beginning of the counter, it should be, all the values should be set. That's why temporary vector is set. Then else if, you have to check for the another condition. Else if, this condition is also checked. If the clock event occurs and the clock is 1, so this is the positive edge triggering, clock is 1, that is nothing but positive edge triggering is used, then the value should be decremented by 1. So this value is decremented by 1, hence the value which is present at right hand side will be assigned to left hand side. So temp, we all set it. On the very next execution, TMP minus 1, the value will be decremented by 1 and will be assigned to TMP once again, and we have to end the process. First of all, we'll end the F, then we are going to end the process. After ending the process, value of Q should be displayed as TMP. Whatever the value of TMP, that will be displayed till the next clock cycle. Why? Because if the next clock cycle appears, the clock is nothing but the sensitivity, and for the change in clock, again the process will be executed and the value of Q will be modified. Okay, that is nothing but the whole architecture, and hence you have to write down the syntax, end and name of the architecture. That's all about the VHDL code for down counter for 4-bit. You can design any counter, any number of bit counter using this program. Okay, so that's all about the 4-bit binary down counter. For more ideas and videos, stay tuned to In 5 Minutes, and thank you for watching this video.